Welcome to Software Patterns and Design with AngularJS. I know, try to contain your excitement. So a small note before I begin, there's been a lot of talk today about Angular 2.0, a lot of excitement and enthusiasm, but this talk is going to be focused on Angular 1.x. While Angular 2.0 is very exciting, we all do have to go back to work on Monday to our 1.3 applications. Yeah. So who am I? My name is Jeremy Elbourn. My Twitter handle is Gelborn. I am a front-end engineer at Google. I work on a couple of DoubleClick products, and I am also a organizer for the AngularJS NYC meetup, and am an occasional speaker there. And I also have a circular avatar photo here, which you may have observed so far is now required by law. Okay. The main thing I want to talk about today is something that comes up as I talk to a lot of developers, both inside of Google and through the meetup, where a question comes up a lot of what is the Angular way to do X, where X could really be anything. And when you're first starting off with Angular, this is a really good question to ask because it will lead you to figure out what makes Angular different from other tools. But sometimes people get so excited about such a cool tool, and understandably so, that they get a little carried away and they want to do everything the Angular way. How do I architect my application the Angular way? How do I sort a list the Angular way? How do I add two numbers the Angular way? Obviously, I'm exaggerating, but there is a point where you have to recognize that Angular is a specific set of tools to help you solve some common problems in web development, and it's not fitted to every problem. So I want to make you see Angular as a set of tools that can be understood in the context of software patterns and concepts that have been guiding engineers for decades. Because we're limited by time, this won't be totally comprehensive, but hopefully I'll cover enough to convey the idea by looking at the biggest, most important pieces. This is going to be covered in 3 sections. First, taking a look at what is inside of Angular through the lens of traditional software patterns and object-oriented design. Second, by looking at some Angular-specific patterns for building clean and maintainable applications. And last, by looking at some anti-patterns, which are always fun. So starting off with traditional software patterns and object-oriented design, we'll start by taking a look at services. Services and how they use dependency injection. So I'm sure everybody in this room is intimately familiar with services and used them hundreds of times. The name service, though, is somewhat arbitrary when you think about it. What is a service in computer science? From a software pattern standpoint, well, you can instead call them injected singletons. For anyone unfamiliar with the term, singleton refers to a class for which you only ever have one single instance. And in the world of computer science, singletons have a few very common uses that I'm sure many of you are already using in these ways. So the first, the most obvious thing is to use them as a cache for application-level data. Since the lifetime of a singleton persists across navigations for your whole application, they make a good place to store data that is used very frequently by wide parts of your application. Another use that is very common is as a facade for browser APIs and third-party APIs. You would want to do this in cases where the underlying API is not to your liking for whatever reason. For example, the HTML5 drag-and-drop API is pretty ugly, and creating your own facade for that API can make your application code much cleaner while also giving you a single point of encapsulation for dealing with that underlying API, making things easier to test and easier to maintain. Lastly, singletons are really good at being factories for creating other objects, a singleton can be configured upon its instantiation to construct objects based on some global state. For example, you can easily create a singleton factory that assigns every object it creates a unique identifier because you can keep a global counter in your singleton. Or as another example, if you're creating objects that all have some set of default properties, but you don't know what the values for these properties are going to be until your application is actually up and running, you can store that global state within your singleton and pump out new objects based on that. The instantiation of injected singleton or Angular services is done with providers, which, to get a little meta, are also injected singleton factories. Now, for all of these uses, these are really good uses for singletons, but you can do a lot of the same stuff with just having some static class. So what is the benefit of using an injected singleton over just having some static object or some static class? Contemplative pause. The advantage of using injection is you have the ability to programmatically swap out the dependency. So the most common application for this is to inject mocks, fakes, and stubs when you're doing unit tests. Going back to our previous example of a drag-and-drop facade API, you could create a fake implementation of this service for unit tests that lets you test your drag-and-drop code without ever actually doing any real DOM manipulation or firing any events. This is going to make your unit tests faster and possibly less flaky when you're dealing with flaky browser technologies. It's also useful beyond testing, though. Say you want to refactor some data cache service that you already have to use the new ECMA 6 Wheatmap API, but you also want to keep your current implementation as a fallback. You can configure your injector to use the appropriate implementation once your application starts running at configuration time. And that way you can get the performance benefit of the more specific data structure in the cases where the browser supports it, but fall back when you can't. So next, looking at data binding, the other major pillar of what Angular is giving you, we can actually look at data binding and see this as an implementation of the observer pattern. This might not seem very obvious at first, but when we think about it, it can make a lot of sense. The idea behind the observer pattern is that you have a lot of different subscribers that are totally independent from each other, but each have some reference to an event channel. The fact that the subscribers know nothing about each other is the most important thing here because it allows changes in your application to be received by many different parts of many different subscribers without tightly coupling them together. This is particularly useful in UIs. So just as an example, if you think about Gmail, imagine you are selecting a single email with the checkbox on that email's row. When you do this, not only does that row become selected, but once you have a selection, your action bars at the top of your inbox change to reflect new actions that you can take based on the selection. The Select All button changes its state to a partial selected state. I don't know if Gmail actually works this way, but doing this kind of thing with the observer pattern is very, very good because your individual email checkboxes and your action bars and your Select All toggle, all of these don't know anything about each other, and you can easily swap them out for other pieces. And as we think about this, this is pretty much exactly what Angular is doing with data binding. In Angular's case, the subscribers are every template binding and every scope watch. The events being subscribed to are data changes. This gives you a very granular and flexible a way to compose your UI based on loosely coupled pieces. And this comes into play with a question I get from time to time, which is how do I have directive A communicate with directive B, or how do I communicate this controller with this directive or this ng controller? And by looking at data binding this way, we realize that Angular has a strong opinion about this, and that the best way for two parts of your application to communicate are simply both to bind to the same data. This approach might not be absolutely ideal for every situation, but most of the time it's going to be what you want to keep things simple and maintainable. And the last pattern I'm going to talk about here is the most basic of all, which is the core of object-oriented design, which is using inheritance. Obviously, everybody understands inheritance and have used it countless times throughout your careers. However, I have noticed a tendency in people using Angulars to overlook inheritance as one of the tools available to you to organize your code. In my experience, I've seen two different situations where inheritance can be useful. The first is to customize or extend services that are sourced from a shared library. So as an example, I work on two different DoubleClick products that share some common services and directives in a shared library. One of these services we use for validation. And the base implementation has a lot of validation functions that are very common, like isValidEmail, isValidDate, and that's really good for the shared library. But then each of the two applications that are using it, they have their own custom validation rules that only really apply within that application. And so they use inheritance to extend that core, that base service and add their own functionality on top of it. Excuse me. The second useful situation for using inheritance is for components, directive controllers in particular. This is really useful when you have some component that comes in multiple different flavors that are kind of on the same idea. In our case, it's a standard select drop-down widget. The base controller handles everything that applies to all of the flavors of the drop-down, such as binding to a list of items, the keyboard shortcuts, the scrolling through the list of items, while the individual child class, the extensions, handle things like, oh, is this a single select or is this a multi-select, and so on. And while I'm talking about inheritance, I'm going to do so with a warning. There are times when inheritance is appropriate, and you should consider it as one tool of many that you can access for a given job. Many times, though, using composition of several encapsulated single responsibility classes or objects is a much more maintainable approach. Of particular note, avoid using inheritance for your normal page controllers that you're getting to from your routes or from ng controller. A page in an application is a very dynamic thing, and tying it into a specific object hierarchy makes it very messy to adapt your application for the inevitable march of new features, redesigns, and reimaginings. So that covers some of the traditional software concepts as they apply to Angular, or how Angular is built. Now I'm going to look at some more specific patterns that are really just for building Angular applications and how they are going to help your applications. The first is the idea of using thick models, and by that I mean models that actually have some methods, some behavior inside of them. A couple of other speakers have already touched on this over the course of the conference, so I'll try to be brief. As your application grows, you'll probably notice that you use the same kinds of objects across multiple different controllers, and so by encapsulating the logic in the models themselves, your code becomes more reusable. An example here, I have two code snippets. On the top, we have doing the logic in the controller. On the bottom, we have it doing it in the model. They're both doing the same thing where you're checking whether or not some item is active based on just a couple of simple conditions. And if you look at these two code examples, they are pretty much exactly the same in terms of complexity. It's only in the organization of the code where the real difference comes into play. In the first example, the function lives on the controller itself and is only usable in that one place. In the second example, that function lives on the item and is usable anywhere where you're binding to that type of item throughout your application. This might raise the question in your mind, hey, my model is just some JSON that I got from the server. How do I decorate it with functions? There are a number of ways you could approach this, such as creating your own API service to do it automatically, or by using HTTP interceptors, or I believe I heard REST Angular can also do it, whatever makes sense for your application. Okay. This next idea is something I call a directive proxy object. Another a common question, similar to the one I posed earlier, is how do you communicate with a directive from a controller, or how do you drive a directive's behavior from a controller? And when answering this, the most important thing we want to keep in mind is that we want to prevent the directive from becoming tightly coupled to that controller. And so in a normal directive controller situation, you just simply have a controller that is data binding two-way to a directive. So they just have some data that's kept in sync back and forth between them by Angular. And we can extend this idea very simply by introducing this intermediate object called a proxy that lives on the controller. The controller creates the proxy and owns it, and it is given to the directive via a binding as if the proxy were the directive's model, which it kind of is. And what does this look like in code? Here we have a page controller that is going to be communicating with a simple directive that is a wizard, a multi-step wizard. So as you see, it just creates a wizard state object. It then binds that wizard state object to the directive. And in order to manipulate the state of the directive henceforth, anytime you need to move forward a step or move backward a step based on some input, you can just simply call on your wizard state next step or previous step or whatever else. The cool thing here is that the controller is now directly interacting with the state of the directive, but it doesn't know anything about how the directive is implemented at all. They just both have this common interface that they both know about. You could use a totally different controller, use this component throughout your application, and the controller is also able to get feedback from the directive by reading the state of this wizard state object without the directive having to explicitly do anything to get that information to the controller, such as firing events or bubbling things up the scope. This is really nice. The last Angular-specific pattern I'm going to talk about is using the idea behind using polymorphism with directives. Polymorphism is a fundamental technique to doing good object-oriented design, and the idea here is that we can explore taking some of the responsibilities and behaviors that normally go into the directive and move those into the model. So an example of the kind of thing you can accomplish with this is rendering a set of heterogeneous items that all share a common interface. So an example from the application I work on is this right here. It is a picture that has a whole bunch of chips in it, where each chip represents a filter that is being applied to a list of data. These filters come in a wide variety of types. You can have date range filters, multi-select, single select, numeric filters with sliders. So you have no real way of knowing what is going to be applied until the user starts applying them. But the key observation to make is that there is a common base for each of these items. They all have a display label. They all have their own little form for editing. They all need to serialize to a key value pair that can be passed to the server to do this filtering. It's clear that we can create an interface for each type of item being rendered. And so as an example, we have here some code that shows a very simple interface that has two filter classes, each of which just exposes a template URL. And they can have whatever other logic inside of them that they need to in order to run. But that template URL is what is going to determine how that filter renders. And we create a very, very short, simple directive that does nothing but bind to a single filter and does an ng include on that filter's template URL and binds that filter object as filter to that filter's template. And in this way, that filter kind of acts as a controller for its own that template, its own edit form. And this is really neat because it lets you create these really flexible renderings that you you don't know what they're going to look like until runtime. This is one of my favorite techniques, and I hope that somebody will be able to take this and find more cool applications for it. Okay? So now we get to the big red section of the presentation of anti-patterns. They're everybody's favorite thing to hear about other people doing. I've come up with some exceedingly clever names for these, and you're really going to appreciate them. So first, War and Peace controllers. These are extremely long controllers that cover several epic code stories and philosophical musings. Obviously, you want to break up your code into smaller, single responsibility encapsulated pieces. Move your code into services or directives or models or static utility objects, wherever it makes the most sense for your application. And in a similar vein, we also have the link function of Doom. This is the same idea, but with a directives link function. I would highly recommend to avoid this and use directive controllers instead. As was mentioned yesterday in the Angular Bootstrap talk, this allows you a lot more flexibility with how you're exposing an API or an interface for your directive. And keep in mind that directive controllers themselves can also get too big and be subject to the same reorganizations as other controllers. Okay. Next, we have what I call forgot about dialogues global state. So we talked earlier about good use cases for singletons, but it's important to remember that there are situations where that's not really the right tool for the job. The idea behind this anti-pattern is that you're using a singleton, such as a service, to store some not global, but instead specific to the current view state. And this usually comes about when someone wants to store some information and make it available in several pieces of the application, such as your application Chrome, on your controller, and in some directives. And the problem is that eventually you're going to introduce some kind of nested subview on your page. Most of the time this is going to be a modal dialog, because let's be honest, who doesn't have a modal dialog in their application? But it could take other forms as well, such as a side pane or a nested view. And once you do this, now you have one route or one page in your application that has two active controllers competing for that global state, and you have to refactor those services. Last anti-pattern is what I call magical prototype chain dependency. This one comes up, I think, more frequent than the others. This is when you take advantage of the fact that Angular uses prototypes for its scope, and you start directly using properties that are on the scope coming from somewhere up the scope chain. Relying on properties like this leads to really brittle code that will break whenever something changes upstream, and will lead you to situations where people on your team are afraid from even renaming anything for fear of breaking something in some dark corner or swept under the rugs part of your application. And taking all of this, I want to come back to that question of the Angular way. And what I really want to emphasize is that Angular applications are still software. All of the design techniques and pitfalls that have been around for 50 years still apply today. So focus less on the question of, is this the Angular way? And instead ask yourself, is this good software? Does it have good separation of concerns? Are components well encapsulated? Is it easy to test? Can you modify small features without large code changes? Those are the questions that will guide you to building great Angular applications. That is all from me. Here's a link to my slides. And if you have any questions for me, feel free to find me later or tweet them to me at Gelborn. Thank you.
Two questions.
I can, I guess.
They can ask you two questions.
Okay. We could do two questions, actually, and have some prizes.
It's better when it's a speaker.
Okay. Right here. It really depends. So the question is, there are other recommendations out there that say it's better not to have logic inside of your models, and it's better to put it inside of services. This is kind of a subjective matter. I think there are definitely times when it is appropriate to have logic in your model when that logic is very obviously tied to how that model exists. So in the example I had of whether or not an item is active, I feel that it's a very strong case where that belongs in the item itself. It's really a judgment call, though. Okay.
Regarding thick models, do you think that having HTTP services inside of models, like REST Angular way of doing models, is something that you would recommend?
Okay. So the question is, would I recommend putting HTTP methods inside of your model objects, which is actually, I believe, called the active record pattern. Yeah. And that is really subjective. Personally, I'm not a fan of it, but I know people who are. It really just matters what the taste of your team is suited to. And if it works for you, go for it. That is all I have. So if you are one of the people who ask a question, you can come and get one of these prizes. And thank you.